Yeah.
Ya llegó. ¿Llegó?
Okay, let's get started, guys. Thank you for joining me today. We have 20 minutes over the time. It's a short presentation, but it's kind of important for me to share this with you. My name is Victor Tort, and this is this is only for the record. It's not an introduction because I know all of you, but this is for the recording of the webinar. Today, I'll be speaking about the protocol analysis. This is the agenda that I have in mind. I'm always open to discuss any topic, but these are the points that I put on the slides. Some quick notes. Wi-Fi is not working. What an IP is, choosing the right tool, frame times, frame header, and the different issues, some issues in Wi-Fi and in wired. So let's get started. I'm going to start with the quick notes. So it's important to getting to know the right place to start when we're talking about the analysis part of the troubleshoot. So I have several points in here. The first one is when troubleshooting a problem, it's always a good idea to follow a concrete steps in order to avoid getting confused in the middle. What it means? It means that we have to really understand what the problem is in order to try to help in a timely manner and in a very short time, and always trying to fix the problem where you are involved in. There are two types of methodologies when speaking in networking world. The ones that are vendor oriented and the ones that are vendor neutral. What it means? It means if you are troubleshooting with one specific company, Microsoft, Cisco, whatever you want, probably they already have some methodology in place that you can follow. But there are other methodologies that are not dependent on the vendor. For example, the CompTIA methodologies or the CWNP methodologies that you can use to troubleshoot any network in general. None of them is better than the other. It's a couple of options only. This is a pretty good one because once a customer calls you, a customer has a problem and it tried to something with the knowledge he has, and he's not able to solve the problem, he will call you. And when the customer calls you, the problem is yours. That is, as I put in the slide, it says sadly, but it's true at the same time. So it's better to take the first point in this slide to really understand what the problem is in order to help the customer and to resolve your problem. So it's better to spend some time from scratch understanding. I'm not saying we don't have to trust the customer. We don't have to believe in what the customer is saying. What I'm saying is in order for you to take the ownership of the case, you have to really understand from the scratch, from the beginning, what the problem is. And the last takeaway is totally different when we are troubleshooting a new network, a new deployment, versus a network that is already in production for several weeks, months, years. It's totally different. So understanding where is the moment of the network is pretty important for us to try to make it faster and better. So how many of us have listened to the customer saying, Wi-Fi is not working? Really? Are you saying to me that a protocol that has been around for more than 20 years is not working? Wi-Fi is not working? Okay, no. Don't say that to the customer, but we thought about it. I mean, it's like, so we need to understand that always in Wi-Fi, not always, but pretty much always, we have two approaches. The problems in the Wi-Fi itself and the problem in the Ethernet part of the network, the wired part of the network. which one of these parts is not working as expected. It's different. So the approach needs to be different as well. This last question is pretty important because getting into the root cause and using the correct tools will depend on the answer of the last question. If we are talking about a problem in one of the network services, we are not using a spectrum analyzer. That doesn't make any sense. If we are diagnosing a problem with Wi-Fi, using a spectrum analyzer does all the sense. So, in order to start this presentation with the technical part, my question in general, you don't have to answer obviously, but it's something to think about it is, what really is an access point? An access point, every time I ask the guys when I'm giving a session or a toy or a presentation, the answer normally it's an antenna, it's a device that is used for RF communication, it's something more related to the wireless part of the communication. But in reality, the access point is a portal. It's a combination of both worlds, the wireless world and the wired world. Actually, the standard defines the access point as any entity that has a station functionality and provide access to the distribution systems via the wireless medium. What it means, you transmit using 800.11, and the access point will translate this information normally to 802.3 or Ethernet standard. So the access point is a portal. It's a portal, and this is always a good point to start troubleshooting where the problem is, because that is the one that has the knowledge in the Wi-Fi world and has the knowledge in the Ethernet world, and it could be probably kind of the same thing in the case of the controllers. But in this case, am I taking in these examples an access point? I'm talking about an access point specifically. So we have to troubleshoot. We have to take an ownership of the problem. We already know that the problem might be in the wireless session. So what tools do we have in order to try to understand what the problem is in the wireless part of the communication? Well, we have several tools. We have a protocol analyzer. A protocol analyzer, we will see it in a minute. It's as well a useful tool in the wired world. We have a spectrum analyzer. We have OS commands of the different vendors. Every vendor has a set of or subset of operating system commands that can help us understand what is happening, and obviously the logs. And on the other side, we have wire troubleshoot, and this is a little bit bigger because in the wire there are too many services for the wireless communication. So, for example, we have the services, and services we call it, for example, the DHCP server, the DNS server, NTP, HTTP, all of these protocols that will allow us to have communication, the Ethernet, all of these part for the wireless part of the communication are known, or are they are known as services, not much a protocol. It's more like services. So we have again the protocol analyzer. We have again OS commands, and we have again logs. No, for example, correlation of the logs using a syslog server with a external database, or the timestamps of the logs, or well-known issues that we might be aware when we are troubleshooting the wired part of the network. A ping command, a trace route, all of these commands you are familiarized already, are kind of our arsenal to troubleshoot the wired and the wireless part of the communication as well. So the next 3 or 4 slides, I will use them as a reference for the troubleshooting in the wireless part of the reason I put it in there was because of that. I need to explain a little bit of this in order to try to explain better the examples I put on the slides. So just a quick reminder, in Wi-Fi world, we have 3 types of frames, not only one as in Ethernet. We have management frames, we have control frames, and we have data frames. The most famous frames are said in the slides: beacon, association, authentication, 18. There are others. For control frames, we have acknowledge, RTS, CTS, and for data, we have simple data, QoS data, and null data. All of these and every one of these has a specific function. It's not my intention to discuss them in here, but it's important to share that we have three types of frames: management, control, and data. And then, as well, it's important for me to try to explain the frame header of the Wi-Fi communication, because I will take it later. So this is a typical frame header in today's network. We have the frame control, duration ID, the four MAC addresses, sequence control, QoS control, and HT control. That is known as the MAC header of the 802.11, and this applied even for AC technologies. Then we have a frame body, which is also known as MSU, and then we have our correction, right? Correction and validation of the data. All of these together form what is known as MPDU. If I go a little bit deeper, again, it's not my intention to analyze one bit per a time, but if I go deeper in the case of the frame control, I will find this structure. So the frame control, by the way, it's 2 bytes long. So if I open this 2 bytes long, I find the following information: the version of the protocol, the type of the protocol, the subtype, and all the way to DS, from DS, more fragment, retry. So as of now, in Wi-Fi world, including probably .11ax, protocol version is always 0. 0 means Wi-Fi as of now, as of today. And then the reason why I'm sharing this, because if we run a protocol analyzer and we try to identify what frame are we talking about, and we will do it via the type and subtype subsection of the frame control. For example, if it's a type 00, that means that we are talking about a management frame. If it's a subtype 08, then it means that we are talking about a management frame that is a beacon besides of that. And then the others, it's I will have a reference some of the documentation I consulted before, so you can take a look of this thoroughly, more than in this presentation. So, for example, I have a beacon frame and I have all of this information. In the left part, I put an example of the information found in the frame control. Protocol version, as I mentioned, it's 0. Management, sorry, type, it's 0 because I'm talking about a management frame. Subtype is 8 because I'm showing a beacon frame. And then we have a to DS is a to distribution system. If this frame is going to the distribution system, to the Ethernet part of the network, in this case it's not. Beacon frames are frames only for Wi-Fi. There is no need to have them in the network. From DS, this beacon is not coming from the network or from the distribution system. It's not fragmented and it's not a retry. The power management is not applying here. I have no more data to send. It's not protected. In this case, it is not protected. It could be 1 in this part, but it's not. I have no to follow a specific order. And the body, I put it a question mark because the body will change. It's not the same. It's not the same in every beacon, and it depends as well in the amendment I am talking about. A beacon is pretty different in .11b, in .11a, in .11n, and in .11ac. It pretty sure will change as well in .11ax. And the reason I'm showing the right portion of these slides is because I want to show you the HT control part of the beacon. That, by the way, this part is for .11n. the portion is different in .11 AC, but this part is for .11n, and the bottom part to the right, it's showing the current channel 9. There is a reason because I want to show you this, because when I took this packet capture, my computer was set to channel 11, and I was able to capture this beacon in channel 9. And the reason why I was able to do that is in the next slide. So let me go to the next slide. That it's Wi-Fi issues. When I say Wi-Fi issues, I mean the most common Wi-Fi issues I've seen in the field. No. For example, let's say that we are talking a new deployment. The customer calls us and he wants us to analyze in a firm's limbs the network part. How feasible is for me to deploy a healthy Wi-Fi network in his premises. So if I go to a customer as a first attempt, as a first approach, I probably want to execute something like these guys. What I'm showing in here, it's a Wi-Fi analyzer. This is always a good starting point, because I'm not analyzing all the spectrum. I'm not making anything. It's like bigger or a huge effort to try to understand what is in the medium and in there. No, I just need to fire up my cell phone, start an application like Wi-Fi analyzer, and with this information, it would be able to tell me, okay, if you deploy a Wi-Fi network in here, you will be competing or you will be sharing the medium with these guys. I don't have to even execute a spectrum analyzer, all of this. In the right portion, it's a spectrum analyzer that it's a more advanced tool than the one in the left, and this is executed by a laptop computer. So let's say that we have to make a new deployment, and that we already see that there is some contention in the Wi-Fi medium, because I already saw some of the Wi-Fi networks that are sharing the same spectrum with me. So if I go to this figure, and you probably guys in the front take care of this image. This is the spectral mask defined in the standard. In the latest roll-up in the 2016, this is the spectral mask that is shown. What it means? When we're talking about channel 1, 2, 3, whatever, 8, 9, 11, in reality, what we're talking is the frequency center. So if you check some documentation, you will find that the channel 1, it's the frequency center of channel 1 is 2412. And there is a reason because of that. If we are talking about this is a typical OFDM spectral mask. The shape is well known. It's not a DSS, it's an OFDM spectral mask. And if we measure in the middle point, we're going to see that the signal is open to the left and it's open to the right. If we are talking that this is channel 1, we're saying that we're be transmitting at the bottom and the lower part of the channel, but as well as long as another 11. What this 11 means is there is the bandwidth. OFDM has 20 megahertz of bandwidth that is known by you, I know. So what you probably don't know, how do I see this in a spectrum analyzer? This is more like a DSS signal. It does not look like, because DSSS signal is kind of, a curve in the top. In the case of the OFDM, is more flat at the top. So that's normal. That is a 20 megahertz channel with, for 40, we have a bigger channel bonding. And if you use a spectrum analyzer, you will see something like this. And if you use a spectrum analyzer that has Wi-Fi integration, you will see in the notes of the tool that this is a 40 megs channel using OFDM. Okay, that is normal. That is our nowadays. That is our best shot to share the medium only with Wi-Fi networks. But guess what? Then you start a protocol, a spectrum analyzer, and start seeing things like this. I mean, in channel 161, it's crowded, but it seems a Wi-Fi transmission. In channel 165, it's not that crowded, and it seems Wi-Fi transmission. But if you see in the middle of the 153 and 157, there is a red mark that I put in there because I see a line that means that someone is occupying this portion of the network, and that is not Wi-Fi. And you know what? The duty cycle of this guy is too high, which means that I won't be able to use this portion of the channel. I mean, actually, I won't be able to use the channel itself. Channel 153 for me, it's prohibited because I'm not able to use it. It turns out that this guy was a TDMA device, time division multiplication access, which means it's not Wi-Fi, but it's using the same spectrum, because the spectrum, I didn't say it, but you know it, the spectrum is shared. I'm not the owner of the spectrum. This spectrum is shared. So I started my spectrum analyzer and saw this. See, what is this? And why is occupying exactly the half portion of the upper part of the unit 3? If it was in the right or in the left, probably I was able to use a 40 megahertz channel, but that is not the case. If I want to use 149 and 143, sorry, and 153, I won't be able to use, because this guy is transmitting constantly, and it doesn't care about Wi-Fi. So this is our first problem in Wi-Fi. This is our first known issue in Wi-Fi. We have two types of interference. Wi-Fi interference, that is nowadays in most of the deployments our best shot, because we have to share. We have Wi-Fi all over the place. But that is not as bad, because if everything or everyone talks Wi-Fi, so that means that everyone is a polite guy or has a polite solution, and it's able to transmit. Probably not as good as we wish, but we will be able to transmit sooner or later. But if we are talking about the other type of interference as this guy, we're not able to transmit, and this is non-Wi-Fi interference. And the non-Wi-Fi interference are well known. It's a Bluetooth, Zigbee, microwave ovens, cordless phones, plasma cutters, TDMA guys that use the same medium, and they don't care about us. So interference, either Wi-Fi or not Wi-Fi, is not good, but it's better for us to have a Wi-Fi interference in order to try to understand if we are able to deploy, at some extent, a Wi-Fi network in the place. Then we have, what is a normal problem? Another problem is about congestion. And congestion, I mean, a few seconds ago I said that it's our best shot is to have to compete against Wi-Fi, but it depends how crowded the medium is. I know Wi-Fi was created to be a polite protocol. That means if someone else is talking, I'm not going to talk. Or if someone else is transmitting, I'm not going to transmit. So in Wi-Fi, in order to avoid interrupting, because if you remember your basic notes, Wi-Fi, there is no way to check to be sure that our frames are delivered if we are not using something called acknowledge. So we have to wait for someone to tell us, I received your information, thank you for sending it. That is not that is the case of Wi-Fi. So if I want to really protect data, I'm going to be able to transmit, and I'm going to permit other guys to transmit as well. I need to be polite. Uh, I have to follow some rules, starting for a physical evaluation of the medium that is called a clear channel assessment. That is the first barrier I put in Wi-Fi in order to know if I'm able to transmit, or if I should wait for my turn. So I will use the clear channel assessment. And in clear channel assessment, I have two options. Energy detected, which means I'm detecting energy. It does not have to be Wi-Fi. I don't have to understand what this energy means. I'm just saying I'm detecting energy above a certain threshold, vendor defined, so I'm not able to transmit. I'm not even trying to make the following steps, as because I'm sensing that it's some energy in the air, and the other it's a carrier sense. Carrier sense is as well energy detected, but in this case it's Wi-Fi. The energy detected is Wi-Fi, so I'm able to understand, for example, how long a transmission will take. No, in this part, still I'm not able to transmit, and this is my first step to protect the information. No, not the information, to protect that I'm going to be able to transmit without being interrupting in the middle, if you want to see it like this way. Then we have another that it's called a virtual carrier sense, and it's called NAV, network allocator vector. In this part of the communication, what I'm going to do is I'm going to hear a signal, and this signal has some part in the frame that say I will use the medium for 100 microseconds. I don't know. That will indicate that I have to reset my clock, my internal clock, to 100 microseconds, and not to try to transmit at this point. And I will start counting down. So I listen to the medium, no one is transmitting. I listen virtually to the medium, and it will take for this guy to transmit its frame 100, 150 microseconds. Then I have to wait all this time. Are these guys enough to avoid collisions? Not. They are not. So that is why I need to put another barrier in the middle that is called interframe space, and there are differences between the type of frame I'm using, type of technology, the five technology I'm using, type of if I have a prioritization. It depends, but the point here is I have to use an interframe space. And even after using the interframe space, I will count down another parameter that is called backoff timer. Once all of these guys are done, I mean, I'm not sensing any energy in the air. I'm done counting down the duration ID. I waited for the interframe space, and I counted out in the back of timer. If every these guys are okay, if the answer is okay, you are able to do so, then you can transmit until that part of the communication. And guess what? If you wants to transmit another frame, you have to go all over again. And the reason, because I put in here is in congestion. It's first of all, if we are sharing with too many Wi-Fi networks, obviously our chance to transmit will be lower and lower. And the second reason, because I put in here, it's if for some reason my frame didn't make it to the other side, I have to wait again to transmit. But in this case, I will use, if you see in this part, in the part of the interframe spaces, I have a different, and the worst of them is the extended, the EIFS. Because if I have to transmit, to retransmit, sorry, I have to wait yes or yes for the longest of the interframe spaces, making my chances even worse to transmit. So if we are seeing a lot of congestion, that probably we want to say the customer to use another band, for example, instead of putting a Wi-Fi network in 2.4, only use a Wi-Fi network in 5 gigs, because this is going to your network is not going to work, and you will be the guilty guy for sure. And then we have the dynamic rate switching. Dynamic rate switching is not a problem itself. It's a solution more than a problem. Dynamic rate switching is, depending on how strong or how near or how good your signal is between the access point and the client, I'm going to be able to use one modulation or the other, and to transmit at certain data rate. Obviously, the higher, the better. But for some reason, if you start moving far from the AP, you are not going to be able to listen it correctly. So that will mean that you have to use a stronger modulation protocol. When I say stronger, it's because you are able to transmit, but you have to use more protection, for example. No, so you can be in the border of the basic service area and start being able to transmit at 1 meg or 2 because of this protocol. But the problem is, what if I have two basic service areas, and they are so located that they are overlapping with each other? So if they are too much overlapping, then it means contention. It doesn't mean exactly what you are able to transmit at lower speeds only. It means that you are fighting, and that is probably one of the problems that I saw in my packet capture before. The other guy was transmitting in channel 9, and I was able to capture the frame because I was transmitting too close at channel 11. I was listening channel 11, but if you remember the spectral max, I'm actually using a little bit more than channel 11. The reason behind using channel 1, 6, and 11 as a best practice in all the books, it is because you are using actually 20 megahertz in the transmission, not only 5. The frequency center of each channel is separated by 5 megahertz. So if you see channel 10 or channel 9, they are only 5 megs or 10 megs separated from the channel 11. So they are somehow overlapping in the communication. But that could be another problem that you can find. If you are capturing in the protocol analyzer, you start seeing different channels in the beacons or in the proof request and response, you probably want to say to the customer that something is not as he expected. And then we have another common problem, that is roaming, and roaming is a huge topic. There are several videos. I remember this one for the CWNAP guys revealing the roaming troubleshooting. It's an art. Honestly, for the different options we have in the market, it started with the only amendment related to roaming, that is .11r. Challenging deploying the .11r with all the security part or with all the time constraints that are involved is challenging to deploy. It's not like you need to know what are you doing in order for it to really work as expected. It has been around for several years. It was ratified in 2008. It was included in the rollup of 2012, and it's obviously included in the 2016, but it's kind of challenging. One of the big problems with roaming is that it's always client's decision to roam from one IP or the other. And that means that the vendor of the client is the one that takes the responsibility to decide when to move and where to move. And then we have other protocols in roaming itself that it's OKC, that it was not standard, you needed software, but it was accepted pretty well, it was robust. And then we have the original ones that is pre-authentication and PM caching. This is another problem that you will see very often in your troubleshoot. And there are others, obviously. The client cannot connect. That doesn't mean anything if you don't understand the problem. It's a configuration issue, it's a misconfiguration, it's something related to security. The client does not support some part of EAP of the PSK was incorrectly. I don't know, probably it's something related to security. The driver is not working. Drivers are not perfect. They are all the time evolving and getting better. Uh, Congestion in the AP, the AP is so saturated. Probably a rule in the AP, band setting, band balancing, load balancing, client admission control, something related to that. Is the SSID being broadcasted in both bands? Probably your client driver only supports 2.4 or 5, and you are radiating or broadcasting your SSID in only one band. That is I mean, those are the most common problems in Wi-Fi. And you have tools. You have tools to try to understand what is happening, and you have tools to fix the problem. The issue is to understand. The takeaway is to understand clearly the problem, and then to make as much uh, as you can to try to resolve. Does that mean that I'm saying that all problems are Wi-Fi related? No, I'm saying that we have Wi-Fi problems, that they exist. We have tools to diagnose. But in my experience as a support guy, I've seen 70 to 80 of the problems are more related to wire issues. So I decided to put some examples as well in the part of the wire issues, so you are able to understand what can you check when you are diagnosing the other side of the coin. For example, let's suppose that you want to deploy a new AP. Well known is that most of the vendors allow you to discover, to auto-configure, and to auto-connect the AP to the controller via the DNS method, the DHCP method, fixed configuration, or probably you can static setting an IP address. But let's say for a moment that you want to deploy an AP that will discover its controller via DNS queries. So you deploy your AP and your AP is not able to connect. How do you know what's the problem? The problem is in the AP. Probably there is not the most secure, but probably the AP is failing. But in this case, what I did was to take a packet capture in the AP and to look for this specific DNS query and say, okay, I'm looking for in the specific site. If you see the reply in here, that is code 3, it say, there is no such name. So I'm the DNS, I understand your query, but I don't have this record on my configuration. What it means that probably with this information, you are able to say to your customer, you did not configure the DNS correctly, or you didn't configure it at all. I mean, I need this specific A-type entrance in the configuration of your DNS server in order to deploy my APs using DNS information. You normally don't have access to the DNS servers. So one way to do it is try to analyze the packet capture if the DNS is responding and it is responding correctly. In this case, it was not. So I got a reply code, no such name, and that is number 3. If you, by the way, all the examples that I have in here, I took them using Wireshark. If you suspect that this is a behavior, you can use this specific configuration in Wi-Fi. It's dns.flags.rcode equal to 3. If you have some suspicion of that, use that specific filter, and you will be able to see the response of the DNS server. Probably this another example is thinking about another problem, a captive portal problem. So you are able to connect to the network. You actually got an IP address, everything is working fine in the Wi-Fi section, but you are not able to reach the portal. I mean, you are in a captive portal configuration, you are redirected. Yeah, you ask, for example, for Google.com, and you get a 302 redirection code in HTTP saying that Google is not longer in that IP and you have to redirect to another IP. But if you try to redirect to the other IP, I mean, you ask for the correct information, and the answer is status code 404, which means it's not there. The URI you are trying to reach does not exist. No, it's not found. So probably you have to go to the customer again and say, customer, I have this packet capture. The protocol is saying this specific URL does not exist. Please correct it, because I am having problem with the captive portal configuration, because no one of my customers is able to reach the portal because of this error. By the way, if you are using your captive portal configuration to use, sorry for the redundancy, IP address, that is probably not the best way, because some browsers do not like not to resolve the domain name. If you want to resolve to 1.1.1.1 whatever, they are not comfortable, and they're going to ask for the DNS. And if the DNS is not answering to that query, you probably will have problems with the redirection. I saw it a couple of times. Even though the theory say that you will be fine working only with IP address, the behavior of the browser is not what we expect, to be honest. And the last example is related to our well friend bootp or DHCP. So one of the problems is Wi-Fi is not working, but we go on site and start diagnosing, and Wi-Fi is working perfectly. So what the problem is, probably the client is not getting an IP address. So, and the reason is it is not getting an IP address can be anything. It can be the DHCP server is depleted, the configuration of the IP helper or the relay in the networking service is not working. It's misconfigured, or there is not the DHCP server in the network, or probably another thing. So what I put in here is again a filter you can use in Wi-Fi, in which you have to change the X for whatever options you are looking. In Wireshark, as of this version, we have 18 between inform, discover, request, acknowledge, whatever. So you are able to use this filter and say, okay, for example, in this screenshot, I put a request using DHCP. So I put a request, which means I'm getting the request from the client, and I put it in the network, and I'm not getting any response. If I'm not getting any response, I have to try another packet capture, or try to diagnose what is happening in the other side of the AP, because Wi-Fi is working fine. I'm receiving the request, but I'm not able. I put it in the network, but I'm not getting any response back. So with this, these are not all the scenarios that you can find in the in the in the network, but it's a subset that is pretty well known. I mean, this kind of problems we saw it in our customers network a bunch of times. So the intention was to try to share a little bit the filters to let it that be clear that you have a full understanding of what the problem is in order to use one tool or the other, or in order to diagnose Wi-Fi part or wire section. It is not like only one problem. I'm not saying that you don't have to trust your customer. Of course, if you have worked with the customer for several years and you know that this guy is a technical guy, probably you are going to trust more in what he does. But still, my recommendation is to try yourself, to try to understand what the problem is, to read whatever you need to read, to execute whatever basic command you need, and after then, you are able to take the ownership of the problem and to solve it in a quicker way, and in a faster way, and in a better way. So the last slide is any question you might have. I'm always open. So now, can you open the micro or read the chat, please? No questions. Okay, that's fine. Thank you all of you guys for joining. Hope I give you some idea of what to do, and see you next time.